Hey guys, welcome back to part 5 of our Endless Runner game tutorial series. In this video, we'll be adding obstacles and making them spawn randomly. Let's get started. First, open Unreal Engine and go to the BP_floor blueprint. Create a new function called Setup Spawn Points. In the BP_runner character blueprint, copy the lane position variable from the variable tab and paste it into the BP_floors variable tab. Drag it to the graph and select Get Lane Position. Add a for each loop node from the lane position variable and connect the execution pin with the function. From the loop body, add a for loop node and set the last index value to 1. From the array element, add a make vector node and change the pin from X to Y by holding the control key. Connect the X pin to a multiply node and connect the first pin of the multiply node to the index pin of the for loop node. Set the value of the second pin to 650. From the return value of the make vector node, add a make transform node. From the loop body of the for loop node, add the add arrow component node. Connect the return value of the make transform node to the relative transform pin. From the return value, add a Get World Transform node. Connect it to an Add Array node and promote the array pin to a new variable called Spawn Points. Compile and save it. Now go to the construction script and drag and drop the Setup Spawn Points function onto the construction script pin. Compile it. And in the viewport, you'll see more arrows spawned. These arrows indicate the places where the obstacles will randomly spawn. We need to change the position of the floor to align with the arrows. Select the floor, change the x-axis location value to 400, and adjust the x-axis location value of the arrows and the box collision by adding plus 400 to their current values. Next, create a new folder in the Blueprints folder called Obstacles. Inside the folder, right-click and create a new actor blueprint named BP_obstacles. Open the blueprint and add a static mesh component from the Components tab. Compile and save it. Now, in the content browser, right-click on the blueprint and create a child blueprint named BP_obstacles_wall. Create another child blueprint and name it BP_obstacles_blocker. Open the BP_obstacles_blocker blueprint. Select the static mesh and change it to shape_cube in the details panel. Adjust the y-axis location to -125, y-axis scale to 0.5, and z-axis to 1.2. Duplicate it by pressing Ctrl+D. Select the duplicated cube and change its y-axis location to 125. From the Components tab, add another static mesh and choose Shape_cube. Adjust the z-axis location value to 120, the y-axis scale value to 3, and the z-axis to 0.7. Select all 3 cubes and in the collision section of the details panel, change the collision type to destructible. Compile and save the blueprint. In the Runner folder, create a new folder called Meshes. Download the box model and the linked texture provided in the description. Import the FBX file as a static mesh and import the texture to the Meshes folder. Once you've done that, open the material blueprint and drag the texture from the content browser to the material blueprint. Connect the RGB pin of the texture to the base color. Delete the parameter node, and from the metallic pin, add a constant node. Change the value of the constant node to 1. Save the material blueprint. Now open the BP_obstacles_wall blueprint. Select the static mesh and choose the imported box mesh. Adjust the size to 1.2 in all axes. Change the Z-axis location to 20 and rotate the box 90 degrees on the Z-axis. Save it. Now open the BP_floor blueprint and create a new function called Spawn Obstacles. Drag and drop the spawn points onto the graph and select Get Spawn Points. Promote it to a new local variable and name it Random Spawn Points. Connect the execution pins. From the random spawn points, add a shuffle node and connect it to a for loop node. From the last index of the for loop node, add an integer in range node and change the max value to 2. From the loop body, add a switch on integer node and add 2 pins. From the selection pin, add an integer in range node and change the max value to 1. The value should match the number of pins added to the switch on integer node. In this case, we have pins 0 and 1, so we select 1. If you had 0, 1, and 2, you would select 2. From the index pin of the for loop node, add a get node. Drag and drop the random spawn points node to the array pin of the get node. From the return value of the get node, add a make relative transform node. Connect the relative to pin to a get actor transform node. For the 0 pin of the switch on integer node, add a child actor component node. In the details panel drop-down menu, select BP_obstacle_wall. Duplicate it and connect it to the 1 pin of the switch on integer node. Change the drop-down menu from wall to blocker. Connect the relative transform return value to both child actor components' relative transform pin. Now, go to the construction script and drag and drop the spawn obstacle pin to the execution pin of the setup spawn points. Compile it. In the viewport, you can see the obstacles, and each time you press compile, their locations change. You can adjust the max index value of the for loop node in the spawn obstacle node to change the density of the obstacles. For me, I found 1 and 2 to be the best. Now let's create a new actor blueprint in the Meshes folder and name it Floor Tiles. Copy the floor static mesh from the BP_floor blueprint and paste it into the Floor Tiles blueprint. Compile and save it. In the level, press Ctrl plus space to open the content browser. From the Meshes folder, drag and drop the Floor Tiles blueprint. In the Details panel, reset the location. Drag it back along the x-axis until the BP_floor barely collides with the floor tile. Repeat the process, but this time drag it until the floor tile and the previous floor tile barely collide. Adjust the player start location as needed, and then press play. As you can see, the obstacles are spawning, and you can slide down the blocker obstacle. This happens because we disable the capsule collision when the slide montage plays. This allows us to slide through the obstacle without any collision. Right after the montage ends, the collision is enabled again. There are other methods to achieve this, but this approach gave me the best results. Other methods sometimes cause the character to fall through the floor or glitch through obstacles. And that's it for today's video. I hope you found this tutorial helpful. Stay tuned for more exciting content. If you enjoyed the video, remember to give it a thumbs up and subscribe to my channel for more amazing tutorials. Thanks for watching, and see you next time.